Hello everyone. Today is the third on screen. So we will discuss about module 3, which is about geometric sequence. So by the end of this lesson, you will be able to define geometric sequence, differentiate geometric sequence from an arithmetic sequence, solve geometric sequence, and find geometric mean or means. So let's have some example of geometric sequence. First one, we have here a figure. It's like honeycomb. So the first one has one hexagon. The second figure has three hexagon. And the third figure, you have 9 hexagon. If you put that in numbers, you will form a sequence that is 1, 3, 9. Meaning there is a pattern that you can have. If you will observe the pattern here is that you multiply the first term by 3 to get the second term, which is 3, and you multiply 3 to 3 to get the third term, which is 9. So that number that you multiply constantly to every term to get the next term is called the common ratio, which is 3 for this case. Another example, for this one, this is a finite geometric sequence, meaning it has a beginning and it has an end. For this one, this is a figure showing an infinite geometric sequence because it is endless, it is continuous, we don't know when it will end. So, basic example of this is a one whole sheet of paper. The area of that is 1. When you fold it into half, the area will be 1/2. Fold that 1/2 into half, then the area will be 1/4. As you continue folding it into half, then the area decreases by a constant. So that decrease is called the common ratio for this case. Because if you will put the area here into sequence, you have 1, 1/2, 1/4, 1/8, 1/16, and so on. So just like in the first one, you need to have a constant to be multiplied from one term to get the next term, and that is a common ratio. If that happens here, then this one is also a geometric sequence. So 1 to 1/2, you multiply 1 by 1/2. 1/2 to 1/4, you multiply 1/2 by 1/2. To get 1/8, you have 1/4 times 1/2. Therefore, our common ratio here is 1/2. And therefore, this figure illustrates a geometric sequence, specifically infinite geometric sequence, because as you fold the paper into half, it is continuous and you don't know until when can you fold that into half. So that's infinite geometric sequence. For the graph of a geometric sequence, let's recall first the graph of an arithmetic sequence. An arithmetic sequence is also known as a linear sequence, right? Therefore, you know that the graph of a linear sequence or arithmetic sequence is a line, a straight line. It could have a positive slope if it is an increasing trend. It will have a negative slope if it's decreasing trend. Now, for geometric sequence, you have this graph, and this represents exponential function. So for this geometric sequence using the bar graph, when you form here a curve, that represents exponential function. That's why a geometric sequence is known also as exponential function. If you will recall, an exponential function is a function wherein the exponent is a variable. So you will see later how is that in this geometric sequence. Why is it the same as exponential function? So the sequence 1, 2, 4, 8, 16, and so on. A sequence where each term after the first term can be obtained by multiplying the previous one by a fixed non-zero number called the common ratio. So for this case, you will observe that each term is multiplied to 2 to get the next term, and that is common ratio. When you have a common ratio, then that is a geometric sequence. Okay? Okay, now that we have or we understand geometric sequence, we'll try to get the common ratio, which is obtained by dividing a term by the term before it. So for this example, 16 divided by 8 should be equal to 8 divided by 4 and should be equal to 4 divided by 2 and 2 divided by 1. If the quotient there is the same, then that is a geometric sequence, or this one is a geometric sequence. So for illustration, when we solve for that, we got common ratio is equal to 2. If it happens that you divide one term to the previous term and the quotient here are different, then that will make a sequence not geometric. Let's see the difference between arithmetic and geometric sequence. For arithmetic sequence, we know that the graph is a line. It increases by a common difference, represented by small letter d, and we perform addition or subtraction to get terms in that sequence. The common ratio can be obtained by subtracting the previous term to the next term, or by subtracting a term by the next term. For geometric sequence, the graph is an increasing trend as exponential function. So, meron siyang curve. And it increases by a common ratio represented by r. We use multiplication or division to perform or to find terms in that sequence. The common ratio is present in a geometric sequence. You can obtain it by getting a common ratio from one term divided by the term before it. Okay, let's try to determine whether or not the given sequence is arithmetic, geometric, or neither. If arithmetic, state the common difference. If geometric, state the common ratio. So for example number 1, let's try to determine if it is arithmetic. So 81 minus negative 27 is actually the same or equal to 108. Then negative 27 minus 9 is equal to negative 36. From here, you can see that these two are different. That makes it not arithmetic. Okay, next, let's see if it is geometric. So that means 81 divided by negative 27. So that is negative 3. Then, negative 27 divided by 9 is still negative 3. Then, 9 divided by negative 3 is still negative 3. So, since this one is the same, then you have a common ratio that is negative 3. This makes it as geometric sequence. Okay? Next. This one. Let's see if it is arithmetic. So you have 74 minus 54, that is 20. 54 minus 34 is still 20. And 34 minus 14 is still 20. So since this is the same, and you use the subtraction property or subtraction as operation, then you know that there is a common difference, which is 20. And that makes this one an arithmetic sequence. Okay. Next, you have this one. Okay, let's try to see if this one is arithmetic or not. Wait. Okay, so that is 5 halves, 5 over 32 minus 1/4. That is LCD of 32, then 5 minus 8. So that is negative 3 over 32. Then you have 1/4 minus 3/8. LCD is 8, and you have 2 minus 3. That's negative 1/8. So they are not the same. So this is not arithmetic. Let's try to see if it is geometric. 5 over 32 divided by 1/4. So when you do that, that's a complex fraction. 5 over 32 times the reciprocal, 4 over 1. So this by cancellation is 8. So this is 5/8. Then you have 1/4 divided by 3/8. So 1/4 times 8 over 3. This one is 2. So 2/3. So they are not the same. Therefore, it's not geometric. So it's not arithmetic, not geometric, so it is neither. Okay? Yes. Next. Okay, so let's continue. I'll be giving you 3 items, 4, 5, and 6, so you can try solving it. You can pause this video and try to solve it. Okay, I hope you did try solving these items. So, to check your work, here are the answers. For number 4, this is a geometric sequence with a common ratio of 1/2. Number 5, this is a geometric sequence with a common ratio of 1/3. And the last one is an arithmetic sequence with a common difference of 5/3. So I hope you were able to solve this one. Okay, for the derivation of the formula, you can use this given sequence. This is a geometric sequence with a common ratio of 2. And then you are looking for the general formula A sub n. So by observing the pattern, just like what we did in our previous lessons, you will come up with this. A sub n is equal to A sub 1 r raised to n minus 1. So this is the general formula in finding the nth term of a geometric sequence. For geometric sequence formula, a geometric sequence or progression, in other words, is a sequence in which each term after the first is obtained by multiplying the preceding term by a non-zero constant. This number by which we multiply is called the common ratio of the sequence. So here is the general formula as we derived in the previous slide. So A sub n is the last term, the A sub 1 is the first term, and n is the number of terms involved in the sequence. Let's try to solve the following. Find the general term and the 8th term of the sequence, 64, negative 32, 16, negative 8, and so on. So let's try to see if what type of sequence is this? Is this a geometric sequence? So you have negative 8 divided by 16. Is it equal to 16 over negative 32? Is it equal to negative 32 over 64? Why do we do that? Because we need to see if there is a common ratio. So for this one, negative 8 divided by 16 is negative 1/2. Then 16 divided by negative 32 is still negative 1/2. And negative 32 divided by 64 is still negative 1/2. Therefore, you have a common ratio of 1/2. So since you have a negative 1/2. So since you have a common ratio of negative 1/2, then you know that this is a geometric sequence. So following the pattern for the geometric sequence, A sub n is equal to A sub 1 r raised to n minus 1. Substituting the values, looking for the general term. So that's A sub n is equal to, your first term here is 64. So 64 times your r, which is negative 1/2, raised to your n minus 1. So this is the formula, the general formula for the nth term of the geometric sequence given. We cannot cancel this because this negative 1/2 is still raised to the exponent. Remember the PEMDAS? You have to simplify with terms or numbers with exponent before you can multiply or divide. So you leave this one as this. Then, to solve for the 8th term, we will use the formula given, A sub 8, the one that we derived. A sub 8 is equal to 64, which is also the first term, times negative 1/2, raised to, your n now will be 8 because that 8 came from this n, minus 1. Okay, this minus 1 came from the subscript, knowing that A64 is A sub 1. Okay, so A sub 8 is equal to 64 times negative 1/2 raised to 7. And 64 times negative raised to add is negative. 1 raised to 7 is 1. 2 raised to 7, 64, 128. Okay? Then, 64 times negative 1/8, you can cancel this. This is 2. So, that makes it negative 1/2. So, your 8th term is negative 1/2. You can do the checking by listing all the terms until you reach the a sub 8. But I'm telling you that this one is correct. Okay, let's try to solve problem number 2. So find the seventh term of the sequence. So seventh term of this given sequence. So we know that we will be looking for the seventh term. Our first term is 3. But we don't know yet what type of sequence is this. It is not stated in the problem. So we will try to see if this one is geometric. So 12 divided by 6 is 2. 6 divided by 3 is 2. And since you have a common ratio, then that is geometric. So your common ratio is 2. Since it's geometric, we will be using the general formula for the nth term of a geometric sequence. So a sub n, since we're looking for a sub 7, will be replaced with this. Then our first term is 3. Our common ratio is 2. Our n here is the same n here. So we have 7 here, therefore we'll have 7 here. This one is the same subscript as to this one. Since we use the first term, then this is still minus 1. Then a sub 7 is equal to 3. Do not multiply this because you still have an exponent there. So simplify the exponent first. So a sub 7 is equal to 3 times 2 raised to 6 is 64. Then a sub 7 is equal to 3 times 64 is 192. So the seventh term is 192. We don't need the conclusion since this is not a word problem. But if you have a word problem, you have to state your final answer in conclusion form, meaning in sentence form. Okay? Next. Let's have number 3. Find the first term of the geometric sequence whose fifth term is 48. So the fifth term is 48. And whose common ratio is 2. So you need to look for the first term. And it was stated here as geometric sequence. Therefore, you're free to use the geometric sequence formula for the nth term. So a sub n, we don't know what is the last term, but we know that a sub 5 here can represent the last term. So I can have a sub 5 is equal to, your a sub 1 is still being unknown. Our r is 2. Your n here, since we use 5 there, it could be 5, then minus 1. So a sub 5 is 48 is equal to a sub 1 times 2 raised to 4. 48 is equal to a sub 1. 2 raised to 4 is 16. So divide both sides. Since we need the value for a sub 1, divide both sides by 16. And this will be equal to 1. So your a sub 1 is equal to 3. You can check by listing the terms in this geometric sequence. Okay, let's have problem number 4. Find the common ratio of the geometric sequence whose fifth term is 9 and whose first term is 1/9. Then write the first 5 terms. So the first 5 terms include the a sub 1. Okay, so since it's a geometric sequence, we will use the general formula for a geometric sequence. So a sub n will be a sub 5, which is 9. 1/9 is the a sub 1. R is unknown, and then 5 minus 1 because we use the fifth term and the first term. So 9 is equal to, you simplify exponent, that's 4. Then divide both sides by 1/9, or since this one is a fraction, you can multiply both sides by 9. So this will be cancelled out, and this is 81 is equal to r raised to 4. But we only need the r. So we will extract the fourth root. Okay? When you extract even root, your answer is always a positive negative. And this can only happen when your radicand is positive. If your radicand is negative and you have an even root, then your root will be with I, or imaginary number. Right? So r raised to 4, fourth root of r raised to 4 is r. Fourth root of 81, so positive root, that is positive negative. The 81 has a fourth root of 3. So that's 3 times 3 times 3 times 3. Same thing with negative 3 times negative 3 times negative 3 times negative 3. They both will give you 81 as the product. So your R here is a positive negative 3. Now, list down the first 5 terms. So you start with your R. If R is equal to positive 3, then your terms will be, first term is 1/9. So 1/9 times positive 3, it will give you 1/9 times 3, 1/3. Okay, next 1/3 times 3. Okay, that is 1. 1 times 3 is 3. 3 times 3 is 9. So this is the first 5 terms if your R is 3. Okay, next, if your R is equal to negative 3, then your first term as 1/9, because it's already given there, times negative 3 will give you negative 1/3. Then, if you multiply this by negative 3, it will give you 1. Multiply by negative 3, it will give you negative 3. Multiply by negative 3, it will give you positive 9. So, this is the next first 5 terms. So, some show this first 5 terms as 1/9, positive negative 1/3, 1, positive negative 3, and 9. So those are the other, this is the other way of writing the first 5 terms of that sequence. Okay? Okay, problem number 5. Find R, or the common ratio, of the geometric progression a over x negative 1, x over a, and so on. So to get the R, we know that the formula to get the R, the common ratio, is equal to a sub 3 over a sub 2. It should be equal to a sub 2 over a sub 1. So R is equal to x over a divided by negative 1. Then negative 1 divided by a over x. So that is a complex fraction. So x over a times reciprocal of negative 1, still negative 1. Then negative 1 times the reciprocal of a over x is x over a. So your common ratio is negative x over a. Yes. So therefore, our R is equal to negative x over a. Don't ask me to get the value of x because it cannot be found for this case. Okay? Next. Okay, so for this one, let's find the missing value of the letters or the missing terms. For this one, the a sub 1 is the first term, r is the common ratio, n is the number of terms involved, and a sub n is the last term being asked in the problem. Okay? So you can pause this video so you can try first before looking or listening to the explanation. Okay, assuming that you were able to try it yourself. So let's try to solve one by one. I'll have here number 1. So for number 1, since they are all geometric sequence, your a sub n is equal to a sub 1 r raised to n minus 1. So your n is 5, therefore I'll have a sub 5 is equal to, you have a sub 1, you have your r raised to 5 minus 1. So a sub 5 is unknown, a sub 1 is 2, your r is 2, then 5 minus 1 is 4. So 2 times this one, 2 raised to 4 is 16. So a sub 5 is 32. Hope you got that correctly. Next, number 2. You have the first term, you have the n, so you have a sub 5 being asked. A sub 5 is equal to a sub 1, which is negative 1, times r, which is 3, raised to n minus 1. Because your negative 1 is the first term. Oh, sorry. Next. Minus 1. So a sub 5 is equal to negative 1 times 3 raised to 4. Negative 1 and 3 raised to 4. 3 times 3, 9 times 3, 27, 81. So 81, then negative 81. So a sub 5 is negative 81. Okay? I hope you got that correctly. So as we continue. Okay, let's have number 3. So number 3, we have here a sub n, or the last term is 96, your n, meaning this one is the sixth term, and the r is 2. So we are looking for a sub 1. So 96 is equal to a sub 1, your r is 2, your n is 6, minus 1. So 96 is equal to a sub 1 times 2 raised to 5. 96 is equal to 91. 2 raised to 5 is 32. Then divide both sides by 32. You will have a sub 1 as 3. 96 divided by 32 is 3. So a sub 1 is 3. Okay? Next, let's have number 4. Number 4. For number 4, your last term is 1024, and that is actually the 11th term. Your common ratio is negative 2. So 1024 is equal to a sub 1, where r is negative 2, raised to 11 minus 1. So 1024 is equal to a sub 1, negative 2 raised to 10. 1024 is equal to a sub 1. Negative raised to even is always positive. Then 2 raised to 10 is 1024. Then divide both sides by 1024. Your a sub 1 is 1. Very good. Next, last number 5. Find the r of the geometric progression. So to get the r, it's third term divided by the second term, and second term divided by the first term. Wait. Next. So it will be 4 over x times reciprocal of 2 is 1/2, which is 2 over x. So this one is 2. Therefore, they are equal and they are your common ratio. So your common ratio is 2 over x. Yahoo! Is that clear? I hope so. Observe that this is a geometric sequence with a common ratio of negative 1/2. These 5 terms between negative 40 and negative 58 are called the geometric means. The geometric means are the terms between two given terms of a geometric sequence. Let's find the 3 geometric means between 32 and 1/8. So, it will look like this one with the 3 blanks between 32 and 1/8. We can use the general formula for the geometric sequence. And we know that a sub 5 is 1/8 and a sub 1 is 32 with n as to 5. Therefore, it's 1/8 is equal to 32 r raised to 4. Simplifying that 1/8 divided by 32, it will be 1 over 256 is equal to r raised to 4. And you get the fourth root of both sides, then you get r as the positive negative 1/4. Remember, when you get even root, you have the positive negative. And when you multiply that positive 1/4 from 32, you will get 8, followed by 2, then 1/2, till you reach 1/8. But if your common ratio is negative 1/4, then the terms will be with the positive negative 8 and the positive negative 1/2. So let's derive the formula for the common ratio so that we don't have to go through the use of the geometric sequence formula. We can go directly to the common ratio formula. So from the general formula of the geometric sequence, dividing both sides by a sub 1, since our goal is to have the r be alone on one side. Then we get the n minus 1 root of both sides so that the r will have an exponent of 1. So basically, our formula for the common ratio is simply the n minus 1 root of the last term over the first term. Remember, your n is the number of terms. You can easily get this as number of geometric means to be inserted plus 2, meaning plus the first term and the last term of it. So that will give you a total of the n in your geometric sequence. So let's try to insert the indicated number of geometric means between the pair of numbers in parentheses. So this is assuming that both terms are from the geometric sequence. So we have 1/8 and we have to insert two geometric means. So using the formula for r, which is the n minus 1 root of the a sub n over a sub 1. So r is equal to our n, since we are to insert 2, then we are given two terms, so we have 4. 4 minus 1 square root of your last term is 8, your first term is 1. So r is equal to the cube root of 8 over 1 is 8. So your r is equal to just positive 2. Okay? So therefore, your geometric means 1, from 1, multiply it to 2, then your second term is 2 times 2. Your next term is 4. Then verify for the last term, that's 8. So therefore, your geometric means are 2 and 4. Okay? Okay, for number 2 example, we are to insert two geometric means between negative 12 and 96. So the general formula for the common ratio is equal to the n minus 1 root of the last term divided by the first term. So your r is equal to, there will be a total of 4 terms. The 2 that you are to insert plus the given 2 terms. So 4 minus 1 divides 96 divided by negative 12. So r is equal to the cube root of negative 8. R is equal to the negative radicand. When you take its add root, it's always just negative. And the cube root of 8 is 2. Therefore, your common ratio is negative 2. So, you have negative 12 times negative 2. It will give you positive 24. And 24 times negative 2, that will give you negative 48. Negative 48 times negative 2, that will give you 96 or positive 96. Therefore, your geometric means are 24 and 48. Okay, next. Problem number 3. 8 1/4. Then you are to insert 4 geometric means. So let's repeat. The r is equal to the n minus 1 root of the last term over the first term. Your r is equal to, there will be a total of 6 terms. The 2 given terms plus the 4 that you are to insert. So 6 minus 1 root of 1/4 divided by 8. So r is equal to 5th root of 1/4 times the reciprocal of 8 is 1/8. So your r is equal to the 5th root of 1 over 32. And the 5th root of 1 is 1. And the 5th root of 32 is 2. Okay? So this is an add root, so you can only take the positive. That's it. Then you have it as 8 times 1/2, meaning divided by 2, that's 4, times 1/2, that's 2, times 1/2, it's 1, times 1/2, it's 1/2, times 1/2 again, that's 1/4. So if you will count it, these are the these are the geometric means. 4, 2, 1, negative 4 to 1 1 half. Okay, is that clear? Okay, this is quite challenging example for you. So let's try to insert 4 geometric means between 3 and 48. So again, our common ratio formula is n minus 1 root of the last term over the first term. So r is equal to, we are going to have how many terms? 6 minus 1, then 48 over 3. Okay, r is equal to fifth root of 48 divided by 3 is 16. So if you will get the fifth root of 16, 16 is just 2 raised to 4. So it doesn't have an exact fifth root. So it will be your common ratio. Now let's use it. 3 times the fifth root of 16. That is simply 3 fifth root of 16. Next, times this to fifth root of 16. I'll show you how. 3 fifth root of 16 times fifth root of 16. That is the same as 3 fifth root of 16 times 16. And that is 3 fifth root of your 16 is 2 raised to 4. We need to express it in exponential form so that we can get an exact root of it, if possible pa, times 2 raised to 4. So by looking at it, this 2 raised to 4 and 2 raised to 4 is 2 raised to 8. So we can break it down as to 2 raised to 5 because we need to get an exact root, times 2 raised to 3. This is the same as 2 raised to 8. Okay? And by doing so, we can get this as exact root. So fifth root of 2 raised to 5 is 2. So you have 3 times 2. Then, fifth root of 2 cubed is still fifth root of 2 cubed. That will give you as 6 fifth root of 8. Okay, next. Multiply this to fifth root of 16. So we have 6 fifth root of 8 times fifth root of 16. So that is 6 fifth root of 8 times 16. 6 fifth root, 8 is equivalent to 2 cubed, and 16 is 2 raised to 4. That is 2 raised to 7. So 6 fifth root of, I can express it as 2 raised to 5 times 2 raised to 2. So I can have a perfect fifth root of 2 raised to 5. So 6, and then this one is fifth root of 2 raised to 5 is 2. Then fifth root of 2 raised to 4 is still fifth root of 4. So I can have, the next term now is 12 fifth root of 4. Okay, next, this one times fifth root of 16. So 12 fifth root of 4 times fifth root of 16 is equal to 12 fifth root of 4 times 16. 12 fifth root of 4 is equivalent to 2 squared times 16, which is 2 raised to 4. So 12 fifth root of, that is, can be expressed 2 raised to 2 times 2 raised to 4 can be expressed as 2 raised to 5 times 2. They still equal to 2 raised to 6. It's equal to 12. Then you have a perfect 2 here. Then fifth root of 2. Therefore, this term is 24 fifth root of 2. Right? Okay. Next, multiply by the fifth root of 16. So 24 fifth root of 2 times fifth root of 16. So 24 times fifth root of 2 times 16 expressed as 24 fifth root of 2 times, so this is 2 raised to 1 and 2 raised to 4. So 24 fifth root of 2 raised to 5. Therefore, it's 24 fifth root of 2 raised to 5 is 2. Therefore, this term is 48, which is actually the last term. Therefore, the geometric means are this. Okay? Quite long because I gave you the exact or the detailed solution. But you can do the shortcut if you can. Thank you. Next. Okay. Now let's go to mean proportional. When we say mean proportional, a term between two terms of a geometric sequence, meaning we only insert a geometric mean. Isa lang siya. Okay, there is a short. You can still use the formula in getting the common ratio, then multiply that to the first term to get the second term. But if you are to insert just one geometric mean or the mean proportional, you can just simply do this shortcut so that you will easily get that geometric mean. Go directly to the geometric mean without solving for the r. Remember, we only solve for the r when we are to insert more than one geometric mean. But if you are to insert just one geometric mean, you can use this shortcut. So, knowing that the common ratio is equal to a sub 3 over a sub 2 equal to a sub 2 over a sub 1, then you can derive the formula for a sub 2. So, a sub 2 squared by cross multiplication, a sub 1 times a sub 3. Then, since this is squared, you get the square root of both sides. And since this is an even root, you always have a positive, negative here. Okay, so your a sub 2, your geometric mean, just 1, is equal to the positive, negative of square root of the product of the first and the last term, or the third term. Okay, so let's find the mean proportional to each pair of numbers. So 3 and 12. So all you have to do is to use this formula. So you solve immediately to a sub 2 or the geometric mean. So that is positive negative square root of 3 times 12. And that is positive negative 36. So that is 6. Okay? So positive negative 6. I'm sorry. It's positive negative 6. Okay? Next. Negative 2 and negative 12. You are to insert one geometric mean. So without solving for the r, you go directly to a sub 2 is equal to positive negative, the product of the first and the third term. That is positive negative square root of negative times negative is positive, and 2 times 12 is 24. Then you simplify it. It can be simplified. So 24 is equal to 6 times 4. 6 times 4. So that is positive negative 2 square root of 6. Okay? Next. Okay, so you can try getting the mean proportional for each pair. So meaning you are to insert a geometric mean between these two given geometric terms. You can pause the video so you can try it yourself. Okay, once done, we can see the answers here. You can try to resolve if you missed this one. So for number 1, the correct answer is positive negative 4. For number 2, the second term is positive negative 12. Number 3, say it as a geometric mean as positive negative 5 square root of 2. And last one is positive negative 7 square root of 3. So make sure you understand also the concept of radicals. So that would be all for today. Thank you. I hope you understand that I wasn't able to attend this class because of my meeting for the about the grading system. That meeting is as a subject coordinator. That would be all. Enjoy the rest of the day. God bless everyone. Keep safe.